here we go. So I know, let me jump over here. Some of you have been waiting on me to make this. And looking at it, the one I got here, I don't think it's, I don't know if this is the same one that a lot of you have. I thought about making these blades because it seems that a lot of other cigar cutters out there probably use similar blades, but I went looking at them. I think the blades I have are different than the ones I've seen. Now I'm going to go ahead and design the cigar cutter, and I'm going to make my own blades, my own blade design. It's pretty much going to follow quite the similar fashion in blade design is what I'm looking at here, but a couple caveats to address the material that we're going to be using to make these, to keep the costs down but keep the strength high. So you're going to see me going back and forth here as I look the design over. And one issue I ran into, see this little spring right here, these are really hard to find. That's a 3/4 inch spring, and the one I bought, bring this up here, the one I bought, you can see it all yanked out. It was supposed to have clearance for this 1/2 inch bolt, but it don't. Well, I went screwing it on, trying to see if I could get it through there, and I ended up having to kind of remount this spring. So this is trash. This is a no-go. And spring was becoming a problem for this little project here. Let me see if I can show you what I did find. I found this spring right here, and if I'm looking at it right, it's a 1/4 inch or 3/4 inch diameter spring here. We should have clearance, bending the little tabs right here so that we can go through this little castle nut that's on the end here. Let's see if I can get that up close. That's going to be quite a challenge. So I'm about to place the order for this spring, and that way I can get the show on the road with this. But for now, we're gonna move along here with CAD designing the body. Let me close up this project here. Oops. That's simulation. Trying to train some of my guys on designing airplane parts with our VF10 and our VF4 CNC machine. So we're going to go ahead and get started here. I'm going to put this under cigar molds. I'm going to make a new folder and cigar cutter. So here you can see a lot of the molds that y'all have purchased from me. I was going to design a heated press. I had this bright idea to take a bunch of electronics, an SSR relay, and put a heated coil inside a fireplace brick that would get CNC machined to hold the coil, and it would heat this up so you could kind of super dry your cigars really quickly, kind of bake in the flavor, kind of like caramelizing marijuana. Is it caramelizing? Carbing marijuana. You could do a similar thing to a cigar, kind of bake in the oils into the flavor of the tobacco while speeding up the dry time. So I never kicked this one off because I ended up using my book press for making cigars, and I bought the AC coils and everything to make it. But as I come into the industry and learn more about it, wasn't sure if this would be all that great of an ideal, so I never moved forward with it. But yeah, there's a lot of the molds that I designed for y'all. Got so many. I still don't have all of them on my store. I steadily add them. And then some of y'all remember this guy right here, which I actually made this. This is the miter saw Cigar Tuck Cutter. I made it battery rechargeable, and it worked pretty good, but I learned a lot about cigar leaf. It likes to be sheared like a pair of scissors, or a tuck cutter. Cutting it with a straight blade, the leaf is pretty resilient to wanting to get straight cut, but it did work with a razor sharp knife or a razor sharp blade as I built. It cut right through it. Just the miter saw needs a little bit more concentricity work to keep the blade perfectly straight with a 3D printed prototype. So that was the only little issue there, and I found a way around it. I just haven't made time, and the primary reason is the battery operation has lasted a long time. I have not ran out the battery in cutting cigars when I was using it, but the pricing point is really high. So my goal here is to not have a really expensive cigar cutter, something that does the job, and I'm like, this thing, something that's not $300 but yet produces a real straight cut. So we're going to go ahead and jump in, and you're going to see me designing bearings and things like that. So some of it will be a little bit of a slow process, but we're going to get the cracking on it right now. So let me bring up our origin here, and I'm going to be back and forth measuring with my caliper, get in some kind of basic dimensions. I don't aim to fully replicate this thing because I have a little bit different ideal for design approach here. Let me switch over to inches real quick. So about 3.8 inches wide. We'll go with about a 4-inch width right here. 4-inch by, let's see here. Let's say about 2 inches. Okay, let me switch my document settings over to inches here. I design a lot in millimeter because I deal with the Chinese a whole lot. Go to inches here, and let's go ahead and measure this bearing 1.5 inches. So we'll go with a 2.25-inch circle here. And then for the Cigar Valley, about 0.8 inches. We'll go 0.9 here. We're going to size it up a little bit, and we'll change things as we go along. Making changes as needed. 0.9 inch. Okay. And how long is it? That's what she said. Let's see here. It's about, say, it's about 8.5 inches in length. 8.5. Okay. Now let's go ahead and let's bearing is just under ½ inch, so we're gonna go off object here. We'll do 1.5 negative. No, don't want to do that. We'll do to object and 1.5. Not what I'm wanting here. Do plus 1.5 inch. Okay. And let's go ahead and make our little track here. What we do to one side, we must do to the other. Let me hide myself out of the way here so I can see everything. Mirror to that line. Mirror that to that. And we're going to come back about that far. Round off these edges here. Let's do 2 millimeter. Actually, let's do 20 thousandths. Yeah, let's do 50 thousandths here. And we'll do about 30 thousandths there. 30 thousandths there. And this bolt, let me get an idea how long this bolt is here. So I'll bring this back up. Inches, okay. So a little bit of ideal here for the length of the bolt. Alright, so 3.35 inches. It's not going to give me a whole lot to work with here. So we'll be coming back to that in a minute. Let's go ahead and put some measurement lines in here. Let's keep it all in inches here, 50 thousandths. And we'll do ½ inch. We want you to be equal to that line there. Pattern this guy here, and we're going to go spacing. Do 8. should be, I'll put center point here. It should be just under a ½ inch there. Let's bring this out a little bit here. And we'll bring that out 0.25 in. What's it? 0.025 inches. Alright, so we're going to cut these in. Kind of 50 thousandths. Well, I doubt you're going to be making a 1-inch cigar. Maybe not even 2 inches, but just for reference, I'm going to have them on there. And we're going to do, what did I do here? Let me go back to that. Okay. And sketch. Oops. Point. That's another one. Rectangle pattern this here. And we want to go back this direction. Spacing -1. And do 8. Probably need to do, yeah, need to 9. Okay. We'll do 8 for now. There's 0.025. And we'll measure from there to there. Oh, that's not what I wanted. We'll keep it right there. Snap a line here. Do 0.2 inches. And I want U horizontal with U. Pattern that. So I'm going to pattern the text. I got an idea. those individually. Unfortunately, I figured that might be the case, so let's go ahead and just get that banged out. It's a little tedious stuff. It's going to take the longest. We're coming over -1. Oops. Should be right there. So, copy. Yeah, I don't know why I didn't snap to the center in the first place. That was kind of -2, -3, -4, -5, -6, -7, -8. Okay. Oops, why did I do that? Okay. That's why I keep doing that. Keep hitting my enter key. 4. Make all 5. And right here we're going to be chopping into the zone a little bit later. I think we're going to go ahead and demark it right here. This will make sense as we come along through the design. What I'm doing here. 25. Let's do 0.3. Yeah, I probably should leave that alone for now. Let's create our bracket here. Let's come out point of, and let's come out, it's about 10 thousandths. thousandths here. We'll come up. There we go. That's no problem. Negative 20. Do the body here. Let's beef that up a little bit. Let's beef it up a little bit. Let's beef up the top a little bit more. Fine. Let me bring it out 9.75. Let's beat that up a little bit here. That's fine. Oops. Come out 80 thousandths here. And let's say we did a 4mm screw hole here to, oops. I gotta redo that one. Nope. Getting that hole centered up. Let's give some contrast and color here so you can kind of see things. high zoom. Thread that. And 4, yeah. And let's go ahead and I could put 1/2 inch, like I want to get really tedious here. Let's go ahead and, I mean, putting a measuring, a lot of you slap a measuring tape on it, but I think it's convenient to kind of have one already on there to just measure cigars by. And then this guy right here, simply move it back and forth. Let me measure this out real quick. 0.2 inches, secondary units, millimeter. So 3 millimeter length screw. We'll probably want to go with a let me activate slide lock component. 4 millimeter by 4 millimeter. And I don't remember the cap size on a 4 millimeter screw. I think they're 6 millimeter. Just kind of eyeball it here. We don't have to model this one out perfect here. We'll just get it kind of eyeballed here. I actually have to order these screws here so that we so we'll have something to actually measure off of. Come back over. Oops, no. 1,000. I'm going to turn this on. Component here. tighten it all the way down. Kind of locking the slider into place. Maybe we need to make that a 5mm rather than a 6mm screw. Let's do that, because that's probably not going to be long enough there. You can poke out a little bit. Now you got a little bit more finger bite on it when you're that's pretty good there. We got our slider here. Let's go ahead and let's make these pop out a little bit more. When I 3D print this design, we can actually have these in white on black, so they're a little bit easier to see. No fast way to really do this, unfortunately. Let's get rid of some of this guy right here. One thing when I'm cutting with the tuck cutter that annoys me a little bit, there's not a whole lot of place to put your hands. Now there is screw mounts on there in case you want to not worrying too much about precision right here, because these are kind of irrelevant, other than if you're going to bolt it down to your, if you're going to screw it down to your table. This way you'll have a little bit more hand area to hold on to it. Before I do, now we can do that. Let's do 12 millimeter. Those are good. These aren't. And we have a little bit of area for a, a screw cap or screw head, if you will. And we can kind of taper them like a taper head screw. Alright, now we can start chopping into the fun shit, which is going to be the blades here. Let me measure out this 1.573, so I'll call it 1.575. It's roughly 40 millimeter. That's probably a metric bearing. Maybe not. So we're going to go ahead and CAD design our bearing here real quick. And it is 12 millimeter. High. Point 4915. Call it 492. What happened there? Alright. Let's go ahead and round these. Actually, before I round the edges off, let's 19 thousandths. Let me move my face out of the screen here so I can see what I'm doing. thousandths down. Thousandths on the inside. And let's do this right here. Okay. $213 thousandths. Oops. Thousandths down. Let's throw a mid-plane in there. Let's mirror this and this to that. Alright, looking a little bit better there. 20 thousandths, 20 thousandths. Let's do that one. That one, 10 thousandths for radius there. Alright, let's move along here. Let's go back over to 0.575, 1.57. Three. 4.7. Oops. I have 0.47. Do a little work on this bolt here. A little bit of challenge with this bolt. So as I'm moving along here, I forgot to account for this little fat, thick part here on the bolt. So this bolt don't go, it's not going to go straight through. It's a little fat part, so my bearing's actually not going to, let's see, how are we going to overcome that situation? It's actually a real problem. I'll get an idea. This is straight, see, the reason I got this bolt is there's a hole already in it, so I don't have to machine that. Saves a lot of time. That little fat-headed part right there, little flare on this bolt, means I can't just butt it right up against the bearing. It's got to ride on the bearing, but also have a recessed cavity for that. So let me back this out right here. Here's what we're going to do. I got an idea. Here's what we're going to do. Let me measure this bolt out. 770, 3/4 pretty much, 775. I got an idea, yeah, right here. 1.75. Alright, so that's where she'll begin. And let's try to measure from that to there. Point 725. And it gives us a little bit of meat. Yeah, gives us a little bit of meat to drop this bearing in here, but we're gonna have to thicken this guy up right here. Let's bring it out. Let's bring it out a little bit here. I'll back that off there. Alright, here's what we're going to do. So I got to redo those measurements real fast. 0.157, 1.557. .573. Back. Okay, we're gonna chop this out of here real quick. .573. Nope. 1.573. 4. So 0.471. Yeah. So we're going to drop that bearing right into there. Oops, shit. Covering it up. Sorry about that, y'all. Trying to run two screens here and getting wrapped up in what I'm doing here. So we're going to have to drop this bearing inside of here. Alright, now we're going to go ahead and put our hole through here. CAD design this bolt. But before we do that, let's put this bearing into place here. Got a feeling that we're going to need to make that slot a little bit bigger. Let's do a section analysis on it. Let's see real quick. Yeah, we can see our bearing diameter is, unfortunately, it's having a cross section with our cavity here, so we're going to have to do something about that. And here's what we'll do. We'll remeasure that bearing. Make it the 1.575. We're going to have to make this a little bit bigger. 1.578. 1.579. Let's do the same thing here. 1.579. Finish. Went in there tight, but I'm going to be that tight. Let's take a look at it again. Section analysis. Yeah, we got a little bit of gap in there, but you can see another problem there. We're good there, but we're not good here. We got to go back a little. We got to make a little more room, or we're gonna have to hammer that damn bearing into there. We don't want to be doing that. So let's come back into here, and we'll go. Negative 0.4. Alright. Let's bring back section analysis. Yeah, we got a little more clearance, but we're kind of. Oh no, we're good. We're looking good. Well, it's gonna be a tight fit. Real tight fit. So just so we don't want it right up butt against there like that. We need to measure this real quick. We got 3/1000ths clearance here. 1.5 thousandths this direction just to see total clearance. Let's go ahead and do that. Now we got a little bit more realistic gap here. But 3D printing tolerance for, I mean, it's a really precise machine that I use. We need a little more clearance. We need at least two thousandths clearance here. So let's go ahead and let's hide the bearing here. And we go negative 0.001. And I'll go half a thousandths that way. Actually, no, we have to bias completely this way, so negative 0.001. Okay, let's bring back our section analysis and our bearing. Well, that should be a tight fit. I think I'm going to give a little more clearance right here. I think we're really going to need that. So it drops right in. Alright, let's CAD design this bolt here. So point 816 thousandths. Should be my 816 thousandths by 377 thousandths. What the hell's going on here? Alright. 640. thousandths here. Measuring apart here, guys. Bear with me. So, 384 thousandths. Thousandths. And measuring apart, so bear with me. I'll pop this up. So, whoa. So we're going to redo that again. Two, 2.567. All right. And then let's check our thread length here. Oh, you know, we have a hole on this thing. I forgot about that. Let me CAD design the hole real quick. $172,000ths. Okay. Seventy thousandths. 172. 192. .07. Roger. Oh, what the hell? That shit went angled. That's not what I wanted. Cancel, I gotta redo that one. Let's bring back that, two. Two, 27. Keeps angling it. Alright. It's wanting to bug out on me here. I know what we'll do to overcome that situation. We're going to bring it up a little bit more. That's about right. Set that crap right there. My CAD's wanting to angle this on me, and it should not be angled. Let's cut it right through. And let's go back to it. Let's see that. Okay. So whenever I think I see what's going on here. Here's what we're going to do to fix that shit. Nope. It'd be a big old pain in the ass right here for this one little simple thing. I'm trying to constrain the sketch to... you know what? I know what I didn't do. like when I design wires. I think this is what I'm supposed to do right here. Let me back it off here. There's our construction plane, which should be floating above, and it is. Okay. So we're going to draw our circle here. And I believe that was 0.172. Okay. We're going to include 3D geometry. We got to tell this thing to no. It's supposed to float that son of a bitch right above there. But yeah, I definitely need to include 3D geometry. What we're going to do is we're going to turn this body into a component. This bolt. This is how the software likes to work. It wants to freak out on me when I'm dealing with multiple components. So I'm just going to. Okay, so it's still not floating above that plane like it should be. So I'm gonna hide the freaking bolt. There. Now we're floating above. Okay. And now we're going to include 3D geometry. And we're going to project this body. There we go. That's what we're looking for right there. We're trying to accomplish the same shit, but had to bust out one of them hidden features there. Let's make sure we got this bad boy centered up. And we want U equal with U. And we want our dimension here to be 0.172 divided by 2 plus 0.7. Nope. What did I do wrong? 0.172. Not. My math ain't mathing today. 0.172 divided by 2 plus 0.7. Oh yeah, 0.07. That was the freaking problem. Hey, where'd you go? Now we bring the bolt back. And now we do that shit right there, which is what we were trying to do the whole time. And boom, we got that hole in there, baby. But we can't thread it with that hole like that. It will throw a computational error. So we're going to model that. And it should be ½ inch. We're not going to do full length. Length of thread here. Boy, putting that little hole in my bolt turned into a pain in the neck. 1.62. 1.62. Alright, and now we're going to bring our hole back into it. Something went funky. Oh, yeah. Must have accidentally moved something. Let's try to thread it with the freaking hole. I have a feeling it's might throw a bitch. Nope. 1.62. Now we're good. Está bueno, vato. Alright, we got our hole here. It looks like a zero. That's probably about 30 thousandths radius there. Let me take a look at the bolt here. Yeah, it looks about 30,000. Point zero. So I can CAD design the main body in under 2 hours. It's all the little componentization work. 0.02. It's all this stuff right here. I mean, I don't have to put the threads in. I don't have to make it look like it's supposed to look in its final version. I could do it much quicker, just doing generic shapes. But I typically like to look at everything. Alright, so our bolt here. Should back that up. We're gonna do a binary cut of that guy and that guy, keeping our tools. And what we're going to do here is we're going to make a little room for this here bolt, because we still have a little bit more work to do. We're going to have to, you know what, I see a little bit of an issue ahead of the curve here. Let's move that guy back. Let me come back into here. Alright, let's if you're wondering what that cavity is about, it's just kind of keep the material costs down, keep the weight down a little bit. Alright, so we've got I've got the steel for the blade. So let me show you that. Software here. Let me my software likes to I got this VCam software running and it throws a background on there. Let me get rid of this automatic background. So I can't really see anything I'm wanting to show you. Let's see, when I put this metal up here. There we go. That'll work. Much better. Alright. So, here's some high carbon plate steel. Let's go ahead and measure. Let's measure how thick this stuff is. This is what I'll be water jet cutting to make the blade, or the blades. .1635, point one, 0.1635. Set it off to the side over here. I actually kind of want to go roll a cigar. I haven't gotten to roll a cigar. Last week I got really busy, and I got a whole bunch of leaf and leaf only. I haven't rolled a cigar, so I'm gonna get. I think I'll get this kind of cracked out here. 0.163, and then I think I'm gonna. Go look at rolling a cigar. 163. We need to come back. Negative 0.163 times 2. We need to come back double the blade thickness. And the reason is we're running out of bolt room here. We're running out of bolt room pretty quick. And unfortunately, by doing that, all these numbers are no longer accurate. I'm gonna have to redo all these. Kind of one of those things as you're getting into the flow. Because right now, if I measure from here to there, we're not an exact 2 inches. So for now, we're gonna get rid of this right here. Let's find where we did all this at. We're going to redo those later because I've got to make little tweaks to the blade zone. We're going to be removing material from here and adding, removing and adding some material to allow room for the blade, so we have enough spring room. Let's see here. Sketch 5. That's not what I wanted. Kind of jack this up there a little bit, huh? I think we can probably pull that into here. Keep that for now. Usually if you're going to bolt it down, you want everything kind of up front here holding it down. We can always come back to that later. So later on we'll put the rulers back into here at a later time. And let's make this a little more ergonomically friendly looking. I don't know what I want to do. include previous sketch. One little thing can just screw everything all up really quick. Let's not do that. Okay. Now, I gotta see what the hell are all these errors here. Let's see if we turn something into Picasso real quick. Alright, not too bad. Well, I'm designing cigar molds for y'all. Sometimes I'll show you real time and you're like, can you make this little adjustment? And by doing that, it'll turn your whole shit into Picasso because of how everything is kind of chained. Alright, so I want to just get rid of those errors. We can come back to creating the screw holes again later. That's not much work. We can we'll put the holes in later. For now, I want to make some progress here with our cutter. We got to get to the cutting part of this whole equation. And so to do that, we need our first blade. So we're going to go ahead and start the blade here. Kind of looking at the blades here, just get a little more scope over. So I see that the bottom blade is kind of angled. So we're going to go ahead and project that. And what we're going to do here is we're going to through. I'm going to throw an angle there. And we're going to let's see here. Yeah, I kind of like the so the blade pops out a little bit, but not too much. I kind of got my blade here popped out a bit too much. Let me add a point here. Kind of drops off right there. And then it looks like we have kind of a slot here. Let's do a 3-point arc slot. Oh, what happened there? Let's do a 4mm thick slot here. Let's do 4.15mm. 4.15mm. And then we'll go ahead and let's trim that up. Alright, let's make our first blade here. And the blade needs to be .157. This is pretty thick. This is pretty thick carbon steel here. It's gonna be a motherfucker to sharpen this bitch. .157. New component. Bottom blade. And more here. And round it off. 'Cause what we're going to do here, hole. And let me just not slap a 4mm hole on there. Let me make sure we got some kind of precision going on here. That. Oh, that didn't turn out right. Okay, there. And let's make this easier. And it seems like this top screw is actually closer to up here. So we're going to shoot it back. Right, go that way. Alright, so what I plan on doing is making an indentation for a nut. Since this will be 3D printed in plastic, if you look at the front right here, let me make this bigger. If you look at the, let's see if I can get this camera to get clear. Right here on the back part of this, we have this little screw right here. Sorry, my camera's going all funky. If you see that screw, what we're doing is we're going into metal here. And while I've threaded plenty of things into plastic, especially the plastic I'll be using for this, it will be real strong. What I'm going to do here to just achieve metal on metal contact is we'll have a little bit of a recess for a nut. And well, I just kind of guessed that hole right there. I don't have the dimensions. I don't have an M4 nut. Let me move this out the way here. I don't have an M4 nut to measure. I'm going to order some. But we can put a nut inside of there, and that way it can't spin on you. And this way you can, when you put an M4 screw in there, which I'm looking at this blade here. And just make it sharp. So this is kind of the best rendition here of how I can just put an edge on this blade here. Now we're going to go ahead and we're going to make our reciprocate, or we're going to make the other blade. But before I do that, let me make this let me make an M4 knot over here. 4mm. Actually, let me do it this way. So, how many, it's gonna be ½ inch, so that's going to be divided by 25. So it's going to be about a 20mm long screw head. Let's see. Body. Oh, never mind. 13. Alright, so we'll probably need like an M4 by 15. Again, I don't have the actual screw on me. I think they're 8mm, or they're 7mm, somewhere around there. Until I get them in hand, I won't have the exact measurements. So for now, we're just gonna kind of design with keeping these things out the way, or to keep things out of the way here. So that'll be our blade. Now we need a top blade. And okay, let's see. Stopper here. So I can tell you right now, we're going to need to bring this guy out here a little bit. Top blade, bottom blade. Got some clearance here. Okay. And we'll back out of that. Just let me go back 2 inches here. Alright. Now the fun begins. We're going to just make a pretty simple little blade that don't really make a whole lot of sense right now. Maybe change it later. Let's make we're going to make the handle. So I'm thinking into this one. We're going to design the back blade, but after we do the handle. So, how thick was that? 0.147. Okay. So, let me double check that again. 0.1547. Okay. 0.1547. What the hell? One 1.547. Getting a little bit dyslexic there. 0.1547. No. 0.1547. Just no wonder. Yeah, that's why. I'm like, what the hell? It was translating it in millimeters. Let me go back to inches here. My brain was getting shot there. I'm like, I need to go smoke a cigar. 1.547. Damn it. You back up, you move there, and do that. There, that mo better. That's mo better. Alright. Okay. So when this thing is opened, when it's closed, it's like that. Open, close. Alright. Let's get our brain wrapped around how we're going to make her open. She's open, we're down. Make a half circle here. Alright, let's think her up. irritating me. There we go. What the hell was that? What the hell was that? Oh. Boom. Alright, so I just need the shape so I know I have enough clearance room to work around here. And I know I need that freaking thing. Zero out my meter here. Let's go half inch, 0.5 inch, that's perfect. We're going to do new body. Actually, no, we need it thicker than that. We need to come out like 0.75 inch. What the hell happened there? Let me go back into there. There. Okay. Shit's starting to look a little more like a fucking cigar cutter, huh? Alright. Let's turn. Now we got some room here for our other blade. See, I offset that the thickness of our blade here. And when I get the real screws in, I'll know a little more about our clearance. So for now, we're just getting her close, getting her where she needs to be at. So now we can do this right here. Oh, no. Let me turn that to a component real quick. You. Go here with you. do a little bit of an offset here. We don't want the bolt being a freaking cram. So 0.00. Let's do 5/1000 clearance here. Let's bring it back, cut it out there. Now we got a little more clearance. Bring our bolt. And let's hide the bolt. We want the bolt to kind of be able to go in kind of easy there. So there we go. Look at that. Oh, nope. We fucked it up. Actually, hold on. Let me bring that bolt back in. Let's bring in our section analysis and take a look. Take a look at the inside here. Alright. Yeah, I guess it would kind of work. But we're poking out. Right there. And let's see our clearance from there to there. 0.144. That's not enough. So what we're going to do here, we need to point, we can go there. So point. No, that's not what I wanted. Hide the bolt here. There. That's no better. And what we're looking for, we need to maintain that 0.155 inch, 155 thousandths for blade gap for the top blade. So we got it there, and looking pretty good. And this right here is looking pretty good. Let's check our analysis from a different direction here. So we have a little bit of room in there. Oops. room to squeeze that bolt in there. Let's hide the analysis out. Okay. Alright, so what we're going to do here is we need to move this guy out the way. And we need to do a cylindrical. The bolt. And we need to come back. Point 1.5. Ooh, she freaked out on us, but I know why. Let's read. We gotta. We need to lock this in with a rigid joint here. Rigid. There. Now we need to do cylindrical joint. You there. To you there. And we need to come back 0.155. We have blade gap. And so we're running out of the problem here is we're running out of space for this nut. So this is why I actually moved this guy in. So here's where we start getting better with the with our joint areas here. I'm going to suppress that. Let me move this bearing out of the way here. You get over there. Let's hide the bolt. Come back -0.2 inches. Oops, don't do that. Let's move you. No. -0.2. Just gonna do that. Aye. 0.2. Can't keep it too thin right there, but we gotta add a little bit of. I mean, most of all actually we're okay because all of the downward force will be applied to the onto the bearing here. That's what the whole purpose for the bearing's for. All right, now you get your ass back over here, and you're a revolute. And all we need to come back 0.0, what's it, 5 1/2 thousandths. Let's bring our analysis back here. Just make sure we didn't fuck nothing up. Yeah, we're looking good, man. We're looking pretty good. just working on this last blade right here. So we got some kung fu to do here, buddy. Let's even if we don't get it perfect right here, not a problem. We'll come back and fix that right up. Oh, there. Let's make the blade go with the profile of the handle. How about that? Let's do that. Kind of jack around with it a little bit here. You know what? Let's come at this with a more sensical approach here. Let's go ahead and back that out. What we're going to do here, I'm going to take this guy and let's not cylindrical. We need a revolute. Yeah, that's what we're after. Revolute. So that's what we're looking for. We need to be at maximum close. And then maximum open. So we want it to kind of, when it stays open, we kind of want it to lock there. Let's say right there, right? So let's go ahead and build in our locking system here. Let's do 9/1000ths right there. Okay. what this is going to do for us is kind of roll that up a little bit. All right, so what that little piece does right there is when this rolls, when this rolls as you're cutting, and it spring loads back into place, it will always lock right there. Won't go any farther than that. So that's our blade open position, if you will. Okay. So now we have our blade open position kind of figured out. What we want to do is we need to know our maximum blade close position, and really would like to have that nut right there, an actual screw. So some of this stuff is going to have to, unfortunately, we're going to have to kind of wait on the finish up design until I get some actual screws in my hands. But let's say we came down a good ways. I don't think we really need to go that far. We can make our blade do all the work for us. But the farther we can go, the more blade area we have. Let's say we did that right there. Alright, so okay. Let's object. I don't want to cut that nut out. Alright, so 1.5. Bring that back. Alright. So we have a little bit of some clearance action there. Alright, making progress here. This is still one of our pain in the asses here. But I got it figured out. I can cut a fucking spring in half. That's what we'll do. We'll just, if the problem I'm having right now is ordering springs that'll fit this whole system. Let me take another look at something here. Alright, so there's a hole into that. There's a hole in there. So there's some things that we just can't do until I get the spring in. Like I need to have like there's going to be a little hole in here somewhere, and I don't know exactly where until I get this damn spring. So one end of the spring will go into here. Let me hide my bearing. So one of the end of the wires on the spring, it's going to be bent, and it's going to be stuck into that hole, so that it kind of engages the spring tension. And then, so we'll have our spring wound up, and then to make this thing rotate the way we want it to, we have to have our castle nut here, which, right, for the time being, this castle nut is going to be entirely 3D printed, which, thought it through, should work out fine. 0.5 inch. Let me hide the bolt. Bring the bolt back. It just, we're running out of tension room is one of our issues. But I think we can make it work. I think by packing down the so if we do this right here, I think that hole was 172, was it? Hide the bolt. Let me see this sucker real quick. Actually, it's just a kind of a round nut. Never mind. Let me redesign that real quick. Not that one. Let me get rid of those. Actually, let me bring some of that back. Let's see, here to there, there to there. No, it needs to be cross-section. That's why I got rid of that. Okay. And I don't know how thick our slot pin will be. It's another little issue here. I don't have a slot pin. I need to find some pins, metal pins. Let's say we could be safe about it and just make it 100,000ths. And make this 100,000ths. From that 0.4 here. Mo better. Put a bolt. And let's see here. Hide this bolt. 0.75 inch. Now this is the hard part. I mean, I don't have to necessarily computer design it exactly the way it's going to look, though it would help. But I'll do my best. Let's do 0.15. Where's the end of that damn coil at? I know what we need to do. We can't just do that. We're gonna have to do 0.05. Okay. Coil. Hide the bolt. No. That didn't go the way I wanted it to. Okay. Coil. That's good. No, let me. No. That's not what I want. 0.03. What the hell happened? 0.03. So 0.7. Or what happened to my coil here? Okay, section there we go. I think that's 0.75. Let me look at this damn coil here. Alright, 0.080 wire diameter. So 0.080. Okay, so that's our section size. Height should be 0.75. Oops. Okay. I see there. No, that's not. Let me do two sides. No. 0.080. New components. And let me do that real quick, but I need this right here. Let me come out 80,000 so I can see the damn. Let me come out a little bit more than that. Well, it's gonna be a cram in this damn spring. It's gonna be a cram, buddy. I need to. let's get the bolt into there. And I'll show you how this puppy's going to play out. So we know it's a .080, so we'll go .09. Well, we'll just make it fucking bigger. Yeah, before I do that, I just see something I need to correct here. Let's make this guy black, just so we can see it a little better. Block. Call this castle nut. Make it into a component. And we need to rotate it a little bit. So we need to be able to have that lock pin in there, fitting through there, and that way that coil tension. Let's come back to our coil here. We've got a little bit of work to do. Damn it, I keep doing it .08. 0.85, it's pretty good. Pretty good. But I don't like that right there. You know what we're gonna have to do? Let's tweak this fucking coil here. 5. This would be more what it's gonna look like when you cram the dog shit out of it, man. Tell you what. She's gonna be crammed the hell up. I'll do 7, 8. She's gonna have some tension on her. Hopefully enough. My biggest concern is not cutting it to fit. It's more. So I know I need to cut it about 0.8 inches in length. I mean, 1, 2, 3. So they don't tell you all the specs on the damn thing. 2 inches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe 12-ish at our halfway point. 12 coils per inch. And, I'm just going to cram the shit out of it and make it work. That's what we're going to do. Hopefully it's going to do what we need it to do. Because the coil spring I have on this one is 67 thousandths. So this spring I'm getting is actually beefier. So I think it'll work. I think we're going to be all right. Let's rotate this puppy around and get a better visualization on it. All right. We're making some progress here. Let's see here. Alright, so this guy here, it's just, okay, so it protrudes through one of the castle nut lock zones. And looks like my damn castle castle nut here, kind of. Ah, that's what happened. Layer 12, layer 13, 15. Okay. So layer 15. Keep that rotated there. What the hell happened? Okay. Now we're going to come back in here and what I have to do, here's what I gotta do. It sucks, but let me see if it's going to let me. Let's see if it lets me do that. Okay, it did let me do that. And now I'm just going to rotate this castle nut again. Okay. So I need to put a hole in here. It lines up with that there. Point nine. Oh, yeah, we'll do 100 thousandths. And let's do a tangent lot to that. And then we know our coil is going to be 0.75. Oh. Oh, I forgot about that. Yeah. Oh no. Yeah. 0.75 divided by 2. There. That no better. Hole right there. Yes, sir, buddy. Alright, now this is the hard part. CAD wise, this is the hard part. We still haven't done this blade. Man, I should stop fucking tweaking on this goddamn spring here. Cause I want to curl this bad boy into there. We have her visualized. Trying to make it fully digitally accurate. Where'd my coil go? Oh. Where the hell did you go? Get out here. Alright, so So this is the fun part. Do 3D sketch, include 3D geometry. And we're going to do a sweep from there along that profile. The body would intersect itself. Yeah, I get that. Alright. We'll just... We don't have enough room. Basically, we're having to pinch this sucker into there. We'll try to sweep it here. Let's see if we can just... We'll just make it do that. Basically, I'm trying to get the end of this to go through that castle nut. What we'll do here is we can just do this right here. Castle nut. Essentially our spring, which is not wanting to completely render properly because the very strong bend radius right here is going to throw a computational error. But essentially that's going to go through there like that. And this guy will actually be coiled up going into here. Like, so let's try to get this one going. This is the stuff that takes a long time. That blade will take me like 5 minutes to do. That'll be easy. Include 3D geometry. Project. I don't need to project that. Actually, one, two, three. Click OK. Do Alright, we're gonna give that one a shot real quick. See if it'll compute. And there we go. That's what we're looking for. Boom, baby. Got a party right there, man. Tell you what. So this nut right here, it will, unfortunately, until I find some kind of a better solution, because making this castle nut, they have to be made. And I could not find them, so I think somebody just machines the shit out of them, which means that I have to kind of design one here, and it will probably be epoxy glued. get it to thread onto there. It'll be screwed onto there and then epoxy glued once the once you get that lock pin in and you get the spring into it. And once I have the spring, I'll be able to measure things a little better. But there's our spring system. Starting to look like a cigar cutter, huh? Alright, let's bang out this blade real quick. This shit should be pretty. It should be pretty easy here. Alright, I think we can. Make this whole thing have kind of like a metal, just a metal backing. Be pretty much all metal. That would make it easy. That would make it a lot more easy. So here's what we'll do on that note. We're going to this would be all the way enclosed here. that kind of, let me get rid of those. Let me copy that. No, not that way. There we go. So we have that counter bite going on. Alright, let's we need to put some holes in it. Stick with 4mm here. Put them close down to the blade area. Alright. Actually, they need to be 4.15mm. Oops, damn it. see if I can get a better angle kind of cut here. Let's well, cutting this shit's kind of hard in the CAD software, but you get the idea. And the only problem here, let me Okay, that didn't play out the way it was supposed to. This needs to be a cylindrical. Cylindrical. Bolt. It's our main body. Bearing. Top blade. Bottom blade. Okay. Cylindrical. pissing me off. Cylindrical joint. Yeah, it's gonna suck it up. Yeah, okay. Let's get rid of that. Where's that at? Okay, capture position. U. Ground. I could cheat and do this right here, and I could get it. I could get it eyeballed on there, but I don't want to do that. But I don't want to do that. Let me try this again. Let me try it one more time. See if it fights me again. It's not supposed to move out of there. It's not supposed to do that. doing these 2-point joints sometimes get finicky. Like they should be. I could be done with this already, but yeah, it's gonna throw it. Okay, let me just not jack with that, and we're doing. And in here, we'll have a bunch of, since this is metal into plastic, we definitely can't just have 7mm. Oops. We can't just have a plastic threading right into, or metal screws threading into plastic. It won't have any strength, so we're going to back it all up to make it strong with metal on metal. By having it go through and locking down into these lock nuts. I think these are going to be 4. I'm going to have to. We're going to have to double check all of these nuts and come back in here and make changes, but you get the idea on this. So the concept here is that we have this was a M4 nut, which I don't have to measure right now. So 4mm in depth. Not to spec. Alright, so I left a little note there to let myself know I need to double check these. 1, 2, 3, 4, 5. When did I make that? Kerchunk. Alright, bada boom, bada bang. We're all done here. I just got to get some screws in, double check all my measurements for my screws, and then get this puppy 3D printed up. I mean, all I'm really lacking is the measurements on screws, and I guess we got one little tiny thing we need to check into real fast, which is from here to there. Alright, so we're gonna need an M4 by an M4 by 20, an M4 by 25. So let's say we had our M4 by 25. Let's finish her up. I think they're 8mm heads. 4mm. Black metal. Oh no. I was going to go bad real quick. Alright, I gotta find some really long M4 screws. We'll be poking out a little bit. Not a lot, but just a little bit. I mean, I could fix that. I know exactly how to fix that. Well, I can just make this right here. Pop out a little bit more. We can fix that so nothing's poking out. It'll probably look better. I'll do that here in a second. That way we'll get these on order. Biggest question of it all. I can tell you right now, it all is going to go together. The only thing I am not fully sure on is the spring that I have on order. That's the only spring I could find that could fit over this bolt, and I'm really hoping that they've got their measurements right, and it doesn't come in, it doesn't fit, because if it doesn't fit, I've got to hunt. I'm going to have to be back to hunting the spring. If it does fit, then I could potentially have this thing ready for you guys by, let's see, how far out does this go? 8.174 inches. I could have this thing potentially ready to take orders as early as possibly later this week. I just got to get the screws in. I just don't have a lot of time. I only get I'm building aircraft parts, so I'm CAD designing all kinds of things for making aircraft parts, and so I get Fridays, Saturdays, and Sundays off. I work 10-hour shifts Monday through Thursday, so that's why y'all haven't been hearing from me a whole lot. Let's put our 4mm. Let's put our holes in here for those that might want to. Now let's go ahead and put that last little final touch back on her that we had. And I think we're just going to come down point. This is really irritating the shit out of me. It's such a simple thing. No, that is irritating me. You know, you make it custom with your name on it. Why not? Huh? And to actually make this custom with your name on it, wouldn't cost me a lot versus like the cigar molds. The cigar molds, because of how they have to be printed, they cost a lot when I do a like white on black logo or name. So put your name right there. See? Nah. I've been live streaming for 3 hours, 55 minutes, so maybe, 2 times the amount. I could have done it in 2 hours, but I wanted to be very particular about it since you're all watching. And kind of show you the final production view of what it would look like. Alright, folks, well, we're done. I just got to get them M4 screws in, spec them out, get them to fit in there, and then we can build this puppy. I got the springs on order, and we can see how this goes. It's going to be quite interesting.